Okay, so volume is, like it says, the amount of 1 by 1 by 1 cubes. So this is a 1 by 1 by 1 cubes that can fill up the space of an object. Okay, so we're literally going to count how many of these three-dimensional little cubes there can be in any given object. Round, square, rectangular, triangular, whatever. Parts of cubes, decimal pieces of cubes that are in a three-dimensional object. So we're going from flat squares to three-dimensional other things. So that's how you draw them with slanted lines that go back to make a, well, in this case, it might be a cube. So let's talk about the different types of three-dimensional objects there are. Okay, there's a whole family of them known as prisms. Okay, and a prism is a three-dimensional object that has two parallel bases. Connected by a height. So the height is always going to be the distance in between your bases. Okay, sometimes your bases are obvious, sometimes your bases are less obvious. Like here is an example of a base that might be less obvious. This is called a rectangular prism because all prisms are named for their bases. So we could have rectangular prisms, we can have triangular prisms, we can have square prisms, we could have pentagonal prisms, we could have trapezoidal prisms, we could have rhomboidal prisms, but normally they're going to be normal shapes, rectangles, triangles, squares, and regular pentagons and such. So named for their bases. So the base is normally the side that faces you. So this might be the base for this, which means the other base would be back here hidden. You can't actually see it in this solid three-dimensional object. But the base would also be back here. So this is a rectangle. This would be the height of your prism, the distance in between your two bases. Okay, so some other things for you to know. Every flat surface is called a face. Whether it's the base of your thing or whether it's the side, any flat surface is called a face. Where two faces come together is called an edge. And where multiple edges meet is called a vertex. So we have faces, which are flat things. We have edges, which are where two faces come together, and then we have a vertex, which can be like a corner of your prism. So other types of three-dimensional objects are cylinders. So cylinder is not a prism because it has no edges or corners, no vertices, but it does have faces. It has circular bases. So if you're going to draw a cylinder, you can start by making a nice oval. Okay, drawing a couple of sides to it, like a can of soup. Making sure the lengths are the same. And then draw another half oval on the back here. And there you have yourself a cylinder. And if you wish, you could put the dotted line for the inside of the cylinder. Okay, for a cylinder, we need to know a couple of things. Here's the radius, And the height for your cylinder is this straight distance, the distance in between your bases. Okay, so cylinders are not prisms, cylinders are cylinders. They can be solid normally for our stuff. Okay, but either way, they all have the same formula. Prisms and cylinders all have the same formula. And that formula is, nice and big, volume equals capital B, that's probably too big, capital B times H. Okay, so yes, it's a nice, easy, gentle formula where big B stands for the base area. And the height is, of course, the height for your prism, the distance in between your bases. So area of the base times the height for all prisms and cylinders. So I should add cylinder down here because it has a similar formula. So for a rectangular prism, if we were to draw our rectangular prism, okay, here's the length of your base rectangle, here's the width of your base rectangle, and here's the height, the distance in between your bases. So for this, the formula is length times width times height. So you just multiply them all together. Okay, pretty simple for a rectangular prism. Okay, for a square prism, let's draw a nice square. Okay, and make it look like an actual prism. Okay, these are of course the same in a square, and that's the height. So for a square prism, x times x is x squared, the area of the base, times the height. So if this were a cube, if they were all the same, a cube is a special type of a square prism where the height is the same as the base. Okay, they're all x. For a cube, the volume is x cubed. But for any rectangular prism or square prism, it's the area of the base, which is a square, so x squared times the height. Okay, a triangular prism, there's your triangular base. So remember, this is the base and the height for your triangle, but there's also a height for your prism. So don't get these two things confused. 1/2 of base times height times a different height. Okay, the height of your prism. So this might be the only one that has this type of thing, unless you're talking about a trapezoid, which also has an h in the formula. So that this one comes from your triangle, where this one comes from your prism. Okay, so these are not the same h's, it's not h squared. Okay, a regular pentagonal prism, so for any regular one, that's 1/2 of the apothem times the perimeter of your prism times the height, the distance in between there. Okay, so there are a couple other types of three-dimensional objects, pyramids and cones. These ones have only one base. So a pyramid is anything that is a polygon. So it can be a square pyramid, it can be a rectangular pyramid, it can be a triangular pyramid. These are also named for their bases. So drawing these is kind of fun. Maybe, I don't know if you think so. So to draw them, you start off by making a parallelogram. So you draw one line and then you draw the other side of the parallelogram, trying to make them look the same. But you finish off your parallelogram with dashed lines. Okay, because this is a solid object and you can't see through it. So you're not Superman. You don't have great vision like that. So there's the base of your pyramid, and we can mark them as all being the same. Sure, with a 90-degree angle. There we know it's a square now. So the next thing we have to do is find the center. That looks like the center of your, if you make the X's, they hit in the center. And from there you go straight up. So however tall you want it to be. So mine's going to be that tall. And then you draw your lines to your square corners. Each of the 3 out here. And then you draw a dashed one to the back. That's how you draw a pyramid. So start with a parallelogram, find the middle and go up, and then draw your lines going to the outside. Okay, cones have circular bases, so you start with a smirking smiley face. Okay, or you can draw a football if you want to call it that. Nice flat one. Okay, where this is the radius. So from the center, once again, you go up however tall you want to go. That's supposed to be pink. Make it a little bit taller. And from that point, you draw your 2 slanted lines to your corners. So for your pyramid and for your cone, this is the height. The distance from the center to the vertex. That is the height. Okay, it does not go up the side, it goes right down the middle. From the vertex, perpendicular to your base. That's the height. So the formula is a fraction of an entire prism or cylinder. 1/3 the area of the base times the height is the volume formula for every cone. Okay, so 3 cones can fit in 1 cylinder with the same dimensions. 3 pyramids can fit into a prism with the same dimensions. Okay, pretty neat that that actually happens. Okay, there you go. Wonderful.